Hello, hello. Ciao, Teo. Welcome back.
Ciao, Luca. Hi, everyone.
And we are towards the end of the summer, right? So,
Oh, well, no, school is back. Come on. It's, to be honest, summer is over, more or less. Come on,
it's
Luca.
over, but today we are gonna keep a little bit the heat of the summer
The
up,
heat is
right?
going on. Come
So
on.
that's the thing. And you and I have been chatting a lot about. I mean, we actually met at the time that Flamegraph were extremely cool and upcoming. The good old Huntsman Giant.
It's worse. It's worse than that, Luca.
Mhm.
We met when generating a flame graph for a Node.js process required, a Solaris machine.
Yeah, that was purely MDB, but you could
Yes.
you need a Linux at least machine that would support dtrace at the time, right?
Yeah, it wasn't working. I never was able to get it to work in there. Then, let's go. Let's take a step back. Okay. So in this episode, folks, we are going to cover flame graphs. Okay. Why? Well, because yesterday we just shipped something new about flame graphs that we're going to talk later in the podcast. So, but that I don't want to keep. I want to keep the tension up so you can keep listening. So, if you have any question for all of that, please ask. Okay, but let's go back to the starting point. Okay, what is a flame graph, Luca?
Flame graph is a very interesting. I mean, first of all, the flame graph is a representation, right? It's not the real data source, but it's basically a representation of stack trace over time. If you want to simplify it at the bare minimum, on the x, so on the width, you represent the total time spent on certain type of operation, and on the y, how deep, so the depth of the stack, just to make it fairly easy, is, well, we will cover later, probably we'll talk later on how it's generated, but imagine that you are continuously sampling the stack trace of an application, and these blocks that you see represented, they are an aggregation of the number of calls over the time span. Just very, very simple.
Yeah. So to going back, the important thing that the important thing that you need to know for you that you're watching. Okay, so you have a CPU performance issue in your app. Okay, and you want to know where your app is spending time. Okay, what you could do is you need to know the functions that are executing at any given time, right? However, if you with all the data you have available, okay, let's say you collect this information. How do you collect that information? Well, you have some tool that take a snapshot of the current stack at a high frequency. Okay, every millisecond, every nanosecond, whatever it is. Okay, it takes a sample of the stack. Okay, depending on the complexity of your application and at which point of the stack it runs. This is generic. If you write a C application, you might want to do that at a very, very high sampling rate. Okay. Anyway, you get the sampling rate and you get exactly, okay, where you're spending the time. Okay. However, you have all these, that at that time specific, at that timestamp, you're spending time in this function and all the call stack. Okay. Now, how do you make that readable? Okay. Well, a flame graph is a data visualization to make that data readable. So it removes time. So it takes all the samples that were took that have the same stack, okay, and wrap them together and put them together, okay, and say, okay, so I have this stack, okay, that was present in my system, okay, 30% of the time, okay. Now you know that CPU, that hot function that is at the top of that stack, it's showing at that for 30% of the time, okay? let's say though that there is another function that is still hot for another 20% of the time, okay? But it has only a part of that stack, okay? So you have two, what we call two flames, okay? Two little flames going up, because one is the first one 30%, this other one is 20%. And when we visualize those things, we visualize them with the share stack all together, and then the two little towers, one next to each other, okay? And that you go on and on and on and on and on, and this is just what our flame graph is rendered, okay?
Yeah.
And yeah, that's probably what it is, okay? And so the history of Flamegraph has been quite turbulent, I would say, Luca. We created a few things as different jobs, different companies, different actors involved. So do you want to talk a little? We started talking a little bit at the beginning. What was there, Luca? So
Yeah.
you want to go and scavenge a little bit of history.
So let's say that in Node, it all started with Joyent, and especially with Brendan Gregg, phenomenal engineer that kind of like took the first step in kind of like visualizing those stack traces. Brendan was deeply involved with a person extremely dear to me, Brian Cantrell, in the definition of dtrace and all the different kind of like utilities around it. Dtrace comes just as a historical thing. We should have an episode about.
That would be interesting.
Back at the old good times of Solaris, and Brian clearly is one of the creators, together with Adam Leventhal. But the very interesting thing is that for the first time, we could actually see exactly what you were saying, the representation, a visual representation of the stack in a very clear way. Probably the most popular, let's say, use case or kind of like a real-time use of a flame graph was the famous or infamous memory leak with Walmart that so involved many people of the first generation of Node. And second was the famous Manta outage that kind of like, I think it really gave popularity to flame graph. Truth has to be told, in the beginning, Node had a different implementation on how to get those flame graph. It was all tightly coupled to dtrace probes. And so you basically found in every sort of framework or in core, all dtrace kind of like traces. And this flame graph was basically a big dtrace query. I personally loved it, but probably one of the handful of people that really enjoyed the dtrace. And then we took a first kind of like step with Dave, right?
No, let me take over, Luca.
Go.
So the problem, so at that point in time, okay, at that point in time, okay, we were able to get like the probes with dtrace, okay, and perf event on Linux. So you could support Solaris, Linux, Solaris and Linux. However, even Mac shipped with dtrace, okay?
Mm-hmm.
But the implementation of dtrace for Mac was a little bit crappy, let's put it that way, okay? It was incomplete. Yeah. And you could not use it, you could not get the name of the functions. So how do you get the name of the functions, okay? You had this bunch of, all of these things that were 0x, and these are address, okay, hexadecimal, and it's a pointer, okay? And the flame graph will report the pointers. And so this function, which is a pointer, okay, was very hot. what the heck is that function? Why you have them? Then they were only pointers and they were dynamic, because V8 was generating those functions for JavaScript dynamically. So you didn't know, you couldn't know, okay, because what was the address of that function to resolve it to a symbol. So
because remember, it's a just in time. So.
It's just in time, yes. So it's a scripting language, it's compiled just in time. So, however, doing some messaging, okay, on a long night, okay, and I even remember the evening, okay. This is Dave and myself were in London for a consultancy, okay, and it was the 14th of February 2016, if I recall correctly, okay, that we were able to crack the problem on how to convert from those hexadecimal symbols, okay, on Mac, so that you could easily generate flame graphs on a Mac, okay, super easily. This is a this was essentially a game changer for producing extremely high quality, so for shortening up the cycle, because then I could, in order to know where I was spending the time, I could just work locally instead of working remotely, okay, and generating them on a server, getting them back. It was a lot of infrastructure to get that information. But if I can run them on my machine, super easy. So this thing, the availability of this tool, okay, and it's still out there, by the way. It's called Zero Access. It downloaded in infinite amount of time, okay. This tool enabled all the developers, okay, to create fast things, okay. For example, a few things that came out from using this tool: Pino, Fastify, okay, and a lot of optimization in Node.js itself, and a lot of other things, okay. But that's not the end of the story. These still required Linux, perf events on Linux, and dtrace on Mac, okay. However, a little bit later, Chrome shipped the CPU profile system in DevTools.
Yeah.
Okay. And Node.js added support for the inspector protocol to connect to be able to for DevTools to access that. Okay. So what we did in 0x was we added the capability to create a flame graph, remove time from a .cpu profile sample, so that if you go to CPU profile, it does not sum up for time. So it's very hard to know. Like, you can know time by time where it was spending where it was spending CPU power for that computation, but it does not do this sum up computation thing. That's very helpful. That kind of view that DevTools gives you is very helpful for frontend, not much for backend. Okay.
Backend, yeah.
So we summed it up. Okay. We were able to generate this nice thing using Chrome DevTools. Okay. But that was able to run without native add-ons, without sudo, without any special setup on Mac, Linux, and Windows. Amazing. Okay. But it's not finished. Okay. That system was very, 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 very high. That system was very, very high cost. Okay. In terms of overhead, more or less 50% performance drop when profiling. So not really useful for production system. Also, it could not sample native code. Okay, that only worked for JavaScript, but that's normally the problem. Okay,
and
so
Theo, probably just for everyone, the process was that when you see a performance issue, you need to launch the process with 0x, and 0x starts the profiling. Then you kill 0x process, the profile stops, and then it starts basically analyzing and generating the flame graph. Right?
Exactly.
That's why
so
a performance.
You needed to do. So while with perf events and dtrace, you could instrument a production system live. The flow for 0x was not that. Okay. Also, it was not that easy because for dtrace or perf events, it wouldn't work inside a container.
Correct.
So
because there is one thing to say is that, for example, in Solaris, the way to get the name of the function with the address was to invoke MDB and ask MDB to also give you the full complete name of the function, because MDB will analyze the memory, right? So these pointers are in memory, so you do the reverse lookup.
Very complex, okay? Very complex, okay? The setup is, it was not simple, okay? So the solution here was, okay, we could do that, okay? Then, sometimes later, okay, Datadog wanted to, and sorry, one thing is missing. Then 0x, when it was 0x later was incorporated in something called Clinic.js that created this Clinic Flame thing, which was a reskin, but also added some useful navigation elements, some UX additions to be able to quickly navigate to the hot function. So okay, this is the problem. And it's highlighting in order. This is the problem, this is the next one, this is the next one, in order. So you can go and fix all of them, okay? However, these tools, okay, all these tools, so the two problems here. First, all these tools, if you have a very big samples with a lot of stacks with large apps, were very slow to render in the browser, like super slow. If loading one could take like 30 seconds in a complex system, like 30 seconds just to load, because each one of them was like a tiny divs everywhere. It was super complex. Okay, very hard, very hard. This is the first problem. Okay, then the second problem. Then the second problem was the performance. Okay, for the performance, okay, there was a company that did some investment here. Okay, which we need chapeau. We quoted Nearform. Now we are quoting Datadog, that took this problem, okay, and released this amazing library, okay, called, let me get you the exact name, because I am going to be, I want to be super precise. So you can find it on GitHub, github.com/datadog/pprof. Node pprof, actually. Sorry, it's the package is called one name in one thing, and the repo is called another. So on npm is at datadog/pprof, which is a fork of Google pprof Node.js. Okay, and so it was forked from Google. So Datadog forked it from Google and
changed the name.
No, and then published it. Okay, and republished it. Anyway, the tool right now it's at datadog/pprof. Okay. This tool was this new library is able to create to sample the stack, okay, using internal V8 APIs, just with an overhead of between 2 to 4%, okay, depending on the complexity of your system. So this is great. We can sample it very fast. Perfect.
And without restarting the process, or still restarting the process?
Without restarting the process. Okay. Also with the inspector we could, but the overhead was too big. Okay. So it was useless. Okay?
Who's gonna open the inspector port in production?
So anyway, this is the gist. Okay. However, this tool was, I don't know, used by Datadog libraries, enjoyed by Datadog customers, but as far as I'm aware, was not really widespread to the masses. Okay, so
and so sorry, yeah. Who wrote this? Do you know the author of the library?
I actually it was authored by Google, but I know the person that did the research actually. You look at who was the person.
Don't know. You tell me. I want you to tell me.
Come on, we hired this guy. Okay, this work was done by our colleague Steven Belanger. He did a fantastic job on this. Okay, so it was fantastic. Okay, and the library it's great. It's a native add-on. Okay, and absolutely thanks to Datadog to keep. To keep stewarding it and using it and maintaining it and doing all the open source work needed here. Okay. So, however, this very cool thing was not super, it created this pip.pprof.pb file, which was not really easy to consume, if I recall correctly. Okay, so what could we do that? Okay, well, we created a new library called react-pprof to be able to render those components. But we created it to solve also the problem with very large frame graphs.
Yeah.
We use WebGL, okay? WebGL is perfect for this use case because you can use your zip to GPU. You need a modern browser with WebGL, otherwise it will not work. But most developers
But who
these days...
doesn't have it?
Yeah, come on, Luca. If you use links, the old 0x generated one would work, okay? Have you ever used links?
Links
the browser.
The browser.
Yes, on the terminal.
Yeah, but I mean, I don't like to self-inflict pain to myself just for. It's I think the nicest thing though about, I mean, what we also have to say is that the reason why Flamegraph are so dear to us, because probably we need to explain that, is that we basically used Flamegraph since the beginning as an instrument, not only for optimizing performance, but also to understand where things were going absolutely wrong. Because you can correlate, for example, the Flamegraph with your ELU usage or with your memory usage. You can actually do a lot of deduction and a lot of correlations that are important to understand modern failures, also non-modern failures. And for us was actually kind of like the reason why we always, one way or another, were connected to Flamegraph, is that basically that's the way how we met, which is kind of like very nostalgic and very kind of like romantic, if you may. But at the same time, that's kind of like, for us was very important to bring the value of Flamegraph to the runtime. Like we wanted to basically have that Flamegraph available in production with no overhead, no headache actually. And then we wanted to make the whole reading experience and finding the issue experience extremely easy for the user, right? It's just, I mean, recently we were at a customer and the first thing that we said was like, just run a freaking Flamegraph and we can see it immediately, right? Well, there is one thing to say, right? Is that Flamegraph, they were never designed with the idea. Well, no, sorry. Flamegraph, they were designed implying that people knew how to read them, but not actually making the reading extremely intuitive and easy for people, right?
Absolutely not. Okay. In fact, I assume, okay, there will be a lot of innovation in this specific area in the next few years. Okay. Specifically because the knowledge on how to read a Flamegraph, okay, I think is automatable, okay, with the help of AI systems. Okay, I think it's a problem that AI systems can help heavily. Okay, especially on the identification side. Okay, and no, because if a function is hard, it's hard. You need somebody to explain why it's hard and potentially recommend a fix. Okay, so. And I think that providing that information to LLM systems could ideally help a lot in this phase. But before jumping into that, okay?
You're already spoiling our next release, so that's. I mean,
come on.
Let's then make it pop. No. Jokes aside, I think you're completely right. I think the big advantage. I mean. Let me take one step into, right? I think actually what we did with this release and what we will do with our next upcoming it's a fundamental change in the world of inspection and preemptive or predictive kind of like.
We didn't explain really, like we mentioned, we shipped React pprof. We didn't talk about the other thing that we shipped, Luca.
No, I was going to.
Okay, come on. Okay.
I was going to say that basically the issue has always been, in my opinion, into the primitive of the runtime, right? And so with VAT, that has been our steward in changing the world in terms of running Node in production, we thought that actually was the right place where to put all these capabilities, right? And say, why do I need to kind of like add an extra step when we know that in production this thing will be needed? And so that's basically what we did with VAT, is to add native, I would not even call support, a native Flamegraph for all the applications running inside of VAT. But I mean, the reason why we did that is very, very simple, is that probably the two of us asked since the beginning why this thing was not out of the box. But I had to know dtrace, I need to do this, I need to do that. And with all the respect to Datadog, why the hell do I need to run Datadog for something that is extremely important for any Node application? So we said, well, you know what? We decided to put it inside of VAT and make it intelligible for everyone. And also give the capabilities to our brain. Our brain, in fact, will be able to get and analyze all this flame graph, because flame graph is always an after the fact thing, right? You agree? It's an after the fact. You see something and then you run a flame graph. But what if it could become a before the fact thing? What if the flame graph is one of the main data sources for doing?
Oh, it's possible, Luca.
Well, for that you need to use our software, and then you're gonna learn. No, jokes aside.
Our system. Okay, so we talked about what we have another component called the command center. This command center is the brain that Luca was referring to. Tomorrow you will see a long article explaining all of this. But as for today, okay, you have, this is a little bit of a teaser. So what we have when this system monitors your VAT, your Node.js application via VAT. Those Node.js application, when there is a signal immediately.
So it doesn't monitor,
it doesn't monitor, by the way. It doesn't monitor. It receives.
It functions like
signals.
A brain.
It functions like a brain, so it receives signals from your application. It doesn't poll, it just receives signals from your app. Those signals include the event loop, CPU utilization, all the things that you know. Plus, when it detects that it's high CPU, high ELU type of situation, event loop utilization, okay? If you see it's stressed, it also collects a flame graph.
This is VAT, by the way. So VAT as local intelligence. So sorry, let me take one thing there, just because it's VAT acts really as one of the synapses in your brain. And that was our main idea, was like, can we actually give intelligence to the runtime itself? Can we make the runtime so smart that basically the runtime itself, so VAT, understands what's going on with all the Node.js processes and makes the informed decision of sending the right signals with the right information to the brain, so to the main computing power, that he will make a decision to, for example, scale up, scale down, scale more threads. And that's actually the kind of like breakthrough model that we decided to implement, because most of the modern systems, they are like collected base, right? You just continuously poll. Even what they sell you that no, but we send information is not true. It's not true. It's just like a reverse thing, because all the local data is very passive. is extremely purely proxying data that comes from Node and push it back to whatever SaaS you are paying for. And we know we are naming indirectly, but for us was actually way more important to give the power to the runtime itself. Why? Because we are a distributed compute engineer, and we believe that having a central point of failure for things is not really the design we would make. And so we just kind of like flip the coin completely and said, can we turn the equation all the way around? I mean, to be honest with you, I think the ICC and by the way, spoiler alert, you will get it for free. You can enjoy it because we believe that we needed to give back to the entire world this kind of idea.
So we're spoiling too much. So
well, you already spoiled the next quarter release.
Come on, for our 20 our 20 watchers. Okay.
Oh no, I was thinking that you were doing like a Mastrota and the 20th person calling today to buy the mattress.
Okay, so you guys, folks, for all of you that are Italian, you know what this is. Otherwise, it's a very famous. It was a very famous Italian presenter that presented the advertisement on TV, offering discounts maybe in the 90s and the 80s, something like that. Okay, and we are old, and we are TV kids. So and
our parents threw in front of watching Mastrota while they were doing something else, and so that's the thing that we remember.
Anyway, it's fun.
We should have pots and pans next time. Call us today, or the mattress, the aiming flex. And this episode is sponsored by.
Okay, if you are a company like that wants to sponsor this thing, we are very happy to take idea.
Yeah, we take everything: mattresses, pots, pans, knives. We should have the chef Tony into this. Oh my God, we took a detour, but. I think what is extremely interesting is that what we are actually adding, and is going to be available very soon, is that we are going to make the reading extremely easy and extremely transparent, because already with our autoscaler we can already compute that, and so we already remove one cognitive overhead from the users. But our mission is really the one to kind of like build this future co-pilot operator, right? And so we believe that the flame graph, the data behind the flame graph and the way the flame graph wants to represent it is extremely important to get into that direction. But Matteo, because today we could make an episode of 7 hours talking about flame graph, and
maybe even not just 7 hours, Luca.
No, the first part, I mean.
42. Come on. 42
yeah, I think,
non-stop. I can do demos over demos and live stream all of it. Okay.
Yeah, but I think it's actually pretty interesting to let's give a sneak peek. Let's help people. So I get a flame graph, but how do I read it? Like I see this thing that looks like a flame graph. Guys, it looks a flame graph because it's usually coloring red and it looks like a flame that is burning. Like
so usually very often is reversed. So you see the flames go under. And the reason for that is because you scroll from top to bottom. Okay.
It was not in that way. So Brandon and Greg have it from bottom up with the foundation, and it was called the flame graph because your system is in flame. That was how it was launched at the old good times. But you are right; it's actually reversed nowadays.
It's way easy. It's way better to render it reverse than in the way Brandon did. It was a nightmare to do that properly.
Because you cannot because of the vertical, right? Because you don't know where the base is. And thanks Apple for doing reverse scrolling. But how do you read it? So
the first part, the key important part. So when analyzing this kind of data, you have two parts. You have a function, and the function have the total percentage of time, total time, okay, and self time. Self time is the time that function was sampled at the top of the stack Total time is the time that was on the stack. Okay. Now, couple of things to know. Okay, over here. First of all, V8 might be lying to you. Okay, so V8 has a concept called function elimination. It's part of a thing called turbofan, which is the optimizing compiler of V8. So V8 might just say, okay, I have a function that calls another function. You know what? That other function that's called, I embed it all together. Okay, for good measure. Okay, why they're doing that? Because it's hot and they can. So that will speed things up a lot. So this is the first thing to know. You don't know. So you don't know that. Okay, you can disable that optimization with a command line flag in Node. I would not recommend to run your system in production with that flag, but if you don't know about this, it's possible to have full stacks over there. Okay, so that's the first problem. Second one, so you know you have the function at the top and it's very hot. Okay, now that function, okay, typically has two problems. The first one is it has a lot of loops. Okay. Or it's friggin' gigantic or humongous. Yeah. Okay. Can be an humongous function. Okay. Sometimes you see those things and they are humongous. Okay. With loops, 2-3 levels of loops, or maybe even a lot of dot for each dot map on massive lists. Okay. A huge amount of object allocations because those are free, right? You know, a lot of those things. Okay. Now, especially if you're doing loops, okay? And you need to start thinking a little bit on computational complexity there and start trimming those loops, okay?
Yeah.
Be careful, though, that usually, you know, two O big O N loops, okay? One next to each other are slower, okay? Even though in computational complexity they are doing two loops, it's identical, okay? Only having one loop, it's way faster in practice, in normal data-sized applications, okay? So doing all these kind of things to minimize amount of time is spent in loops, okay? Or maybe even stuff that is generated, you can implement some sort of short mode caching, LRUs, can be a lot of things, okay? I don't know, it depends on your code, okay? One thing that is usually hitting a lot of people, and let me mention them, okay? It's, for example, calling date.now or new date. This is one of the most ridiculous ones, okay? Because it talks to something else, okay? So these, when you do date.now, this in fact is a call from JavaScript to C++, from C++ to the frigging operating system to get your the time of the computer, okay? This is a lot of hard work. Like, it's relatively a lot of work to get that information, okay? So in order to get it fast, okay, you probably want to cache this, okay? Now, a lot of you might know or might not know, okay, that each HTTP response includes the full time of the system, okay? So that means that we need to do all this work for each time. But that time that is rendered has a precision of seconds, okay? So Node.js, in order to avoid all of that work, cheats a little bit, not badly, okay? Cheats. And it takes, instead of doing all of that, okay, it just, it take the time now, okay, and then it schedule a timer for 1 second later to clear the cache. So every time it schedules a timer to clear the cache in 1 second. In this way, if more requests are arriving in 1 second and it can process 100,000 easy on modern hardware, okay? So in that second, it's only going to get that expensive call only once. And that is why that's not a problem for HTTP calls, okay? But a lot of people don't know, they use this field in updated at or in other things, so you might need, this is actually Also, one of the reasons why using date.now is not a good use for a hash, for example, or disambiguating things. Okay. So that thing, okay, it's that thing is actually very very good. So this is the second part. Okay, so there is some computation that is going to C++, or it's very expensive on its own, but it's not implemented in your code. It's a call to something else. Okay, that gets embedded or removed and so on and so forth. So for example, if you need fast hashing, if you need fast IDs, okay, you have more or less two options, I would say. One is using crypto.randomuid4. Okay, that is pretty good. It's part of Node Core now. You can get relatively good fast UUIDs. Okay, they're not the new V7 that are orderable, so keep that in mind. Okay. The other one that you can use that is not a UUID, okay, but it's fast, okay, faster than that and faster than probably any other alternative out there. Okay, it's called HyperID. On the last benchmark that I did on Node 22, I could get what it is 25 million ops per second versus crypto random UUID was getting like 13 million. Okay, and like
but Theo, before we end up in 42 hours of explaining everything.
Yeah, of course. Oh, by the way, we are at 42 minutes almost of the recording.
And
so
how do you identify with your with the blink of an eye in the flame graph which one is the function?
So I take a look at the largest, okay, that is at the bottom of the flame graph. Okay, so the largest that have the biggest self time.
So because of the order of things, the largest block closest to the end of the stack.
Yes, exactly. Yes. So the largest block that have the largest path that has nothing on top.
Yeah.
Okay. That has no other thing on top of that block. And that is critical. That gives you the exact specific thing where to focus your effort.
Now, so we demystify how to read it.
Yes. But you know what? The problem might not just be on that file.
Correct.
Okay, because, or it's not the problem there. Like the problem might not be on that file because the solution might be that you need to cache some value. And in order to cache it, you might need to cache it 1 or 2 or 3 layers down. So usually those things are, you could cache them easy, okay? And it's pretty good. So why not?
Yeah, and Theo, I think we are almost at time. So let's do this. I think a flame graph day should be a topic that we go and continue talking about. So let's pause it for now, and maybe we can see next week if we can continue this chat so that people can continue.
We have another surprise next week, so maybe in a few, but yes.
Let's see when, but let's pin it. For now, we told everyone where they come from, what they are, and how to read them in a glance, like, blink of an eye. And then we can go deeper into some of this correlation later on so that we can deep dive. So for today, I would say that was a nice chat. Nostalgic, full of nice meat, and I hope of value for everyone listening to us. So let's say goodbye to everyone and we meet next week. Bye. Ciao, everyone. And don't forget to check our release. You will love it.
Yay. Bye, guys.
Bye. Ciao.
Bye. Ciao.